We have 5 lectures together, right? Today, the first lecture, we're going to talk about basically the equation systems that we're going to use. And we're going to talk about the shallow water equations. We'll talk a bit about variable transformations, coordinate transformations, and a little refresher on vorticity. Next week, I'll give you a thorough grounding in quasi-geostrophic theory, something you may have heard of or used and possibly have limited understanding of. After next week, you'll understand it perfectly. Okay? Week 3, Rossby waves. You've all seen Rossby waves before. We're going to go into much more detail about Rossby waves and instability. And week 4, we'll go into the tropics, and we'll talk about gravity waves and many other types of tropical waves. And the last lecture is a bit more descriptive. We'll have a bit of a tour of various phenomena, nonlinear phenomena in the atmosphere and ocean, which are to do with scale interactions. Right, so what do you need to know to follow this course? Well, here are the things I hope you know already. Partial differential equations, vector calculus, so you have to know a little bit about derivatives and derivatives of many variables, divergence, curl, rotational, okay. Hope you know what the Coriolis force is. I don't have to explain that again. And geostrophic balance, you must remember what that is, okay. Basic equations of motion, you know them by heart, I'm sure. And vorticity and divergence, I'm not sure how much you know about that, so we will give you a little reminder about that, okay, today. Here is a list of books. The course is basically taken out of these books and a few other bits and pieces. Geophysical fluid dynamics. It's the study of fluid dynamics on rotating planets, often when there is some stratification in the fluid, right? So the planet's rotating and there's a variation in density in the fluid. That's the essence of geophysical fluid dynamics. And so the important keywords there are rotation and stratification. We will talk about balance and development. So balance is basically any system of equations where there's no time derivative. Okay, so it's a system which is not developing in time. Therefore, there is some sort of balance between the terms in the equation. So the simplest type of balance that you know is geostrophic balance, right? So that's just the balance between pressure gradient force and Coriolis force. Okay? We'll look at that. Development, on the other hand, is when there is a time derivative in the equations. And nonlinearity is very important. A lot of effects from the fact that the advection terms in the equations are nonlinear, so that gives you a nonlinear dynamical system. Chaos ensues, okay? Now, here are some words which we use to describe the way in which density varies. So we'll just go quickly into what that means. Homogeneous, Boussinesque, and anelastic. We'll talk about what barotropic, baroclinic means. Barotropic flow, baroclinic flow. I'm sure you've heard that before. Perhaps you still have notions about it which are a little bit vague, so we'll firm that up for you, okay? And then stationary flow, transient flow. We'll talk about that. The variables we use are basically the flow velocity, the pressure, the density, and there are alternative variables which we can use, like layer thickness. If we use a layer model, then the thickness of the layer will tell you something about the stratification of the fluid. Right? Vorticity and divergence, which can be used as state variables instead of the wind or current, instead of the flow velocity. Or even equivalently, you can use stream function and velocity potential. So these variables are all useful depending on which equation set you are solving. And we'll start by looking at the shallow water equations. Now, you've seen the shallow water equations before. You saw them last year. We just used them without much explanation. So we're going to derive them in some way here. We'll talk about external and internal modes, and we'll finish off just with a summary of circulation and vorticity. So that's a lot to do in one day, so get on with it.